Okay, now that you know a little bit about properties of ionic compounds and what it means for something to be an ionic compound, we're going to talk about, okay, well, how do we name these things, okay? Now, it's a lot harder to name an ionic compound than it is to name a covalent compound. And a lot of you have seen this before, especially in physical science, so let's just kind of do a rundown of what we're going to be doing. First of all, we're going to talk about monatomic ions. So monatomic ions are easy, okay? These are ions that just are one element that has a charge, okay? So for example, what we've talked about so far, like group 1 has a +1 charge, group 2 has a +2 charge, aluminum is +3, and then anions are nonmetals that gain electrons. This is a new thing here. These are going to end in "ide." Monatomic ions, anions, end in "ide." So group 15, where nitrogen is going to be -3, and it's going to be nitride. Okay? Group 16, -2, oxide. Okay? Group 17, the halogens, -1. So this would be like fluoride or chloride. This is one of the reasons why sometimes you hear halogens also referred to as halides, okay? And then group 18 has no charge, therefore they don't mix with anything, so they won't be in anything that we name, okay? But what about the rest? We kind of skip over the whole transition block, okay? Ions of transition metals can change, okay? And this will be dependent on how many electrons that transition metal loses, okay? So for example, iron can have 2 different charges depending on how many electrons it loses. So if it loses 2 electrons, it would become +2 iron, so Fe +2. If it's iron that loses 3 electrons, it'll be Fe +3. Okay, now it's really important because we're going to have to pay really close attention when we start naming these, how many electrons are being lost. So if I was to name these, I would say iron 2. The Roman numeral indicates the charge, okay? And then the second one would be iron 3, okay? So those are ions of transition metals, okay? Except for, and you need to have these memorized, there's 3 transition metals that only lose 1 or 2 electrons ever, okay? And those 2 are zinc is always +2, cadmium is always +2, and silver, or Ag, I'm sorry, I'm writing it like this, is always +1. So zinc is always +2, cadmium is always +2, and silver is always +1, okay? So the transition metals, I say that their charges are wishy-washy. They don't really know what they want to be. And then group 1, group 2, aluminum, zinc, cadmium, and silver always have the same charge. Okay, group 1 is always +1, group 2 is always +2, aluminum is always +3, and then zinc, cadmium, and silver are charged as they're shown. Okay, and then the last type of ion that you can have is a polyatomic. These are the ones that you're working on memorizing on that yellow piece of paper, okay? Polyatomic means many atoms in an ion, okay? So these are composed of more than one atom. Most, all, but not all of them end in ate or ite, okay? Ate always has 1 more oxygen than ite, okay? But those are just pure memorization that I need you to work on, okay? So in this lesson, or for the rest of this lesson, we're going to talk about naming binary ionic compounds. So binary means 2. So this is going to be a 2-atom ionic compound. Okay, so binary means 2. Ionic means ions. Okay, so 2 ions in 1 compound. Okay, so again, this is just review. Group 1 always has a +1 charge. Group 2 always has a +2 charge. Aluminum always has a +3 charge. Noble gases, no charge because it doesn't form a compound. Halogens always have -1. Oxygen and sulfur always -2. And then nitrogen and phosphorus always -3. Okay. The goal for writing a correct formula for a ionic compound is that the negative and the positive charges cancel each other. Okay. So we're going to write cancel. I'm sorry, I always mess that up. Cancel. And how are we going to do that? We're going to crisscross the charges, and it's going to tell us what it's going to look like as a compound, okay? So let's just look at a couple of examples here and just running through these, and the more practice, the better, okay? So you always ask yourself, there's two questions. Do the positive, so the cation and the anion charge, cancel each other out? If yes, then you're just going to write the two ions with no subscript, okay? Subscript is the number below the letters. If no, then we need to crisscross the charges, so crisscross the charges, and make the charges the other atom's subscript, okay? So let's look at the first one. So if the charges cancel, look, magnesium is in group 2, therefore it'll have a +2 charge. Oxygen will have a -2 charge. Charges cancel each other, therefore my formula will just be MgO. Okay? If the answer is no, I need to crisscross the charges and give them to the other atoms, meaning magnesium has a +2 charge, chlorine has a -1 charge. +2 and -1 don't cancel. Therefore, the 2 goes to the chlorine and the 1 goes to the magnesium. And we can see this on the next page here. Okay? So the 2 goes to chlorine and the 1 goes to magnesium. And the formula here is going to be MgCl. Now let's think about this, why this is the case. Okay? Magnesium is losing 2 electrons, but chlorine can only accept 1, okay? Meaning, I'm going to need 2 chlorines to accept 2 electrons from magnesium, right? So it would look something like this. Magnesium with his 2 valence and chlorine with his 7, right? And this chlorine with his 7. Magnesium would have to give one of its electrons to one chlorine and the second electron to the second chlorine. And that's why the crisscross of the charges works for us. Okay? So that's how you get the formula. How do I name? These are simple. The cations read as is, and then I add "ide" to the end of the anion. Okay? So for example, NaCl. The cation is sodium. My anion is chlorine, but I'm going to drop the "ene" and add an "ide." So it's going to be chloride. Okay? So this compound would then be sodium chloride. Easy enough. Let's look at the next one. Magnesium is my cation. Oxygen is my anion, but I'm going to drop the gin and add an "ide." So it's going to be oxide. So then this is going to be magnesium oxide. Okay? Easy enough. So now we're going to practice these, okay? Because practice makes perfect. All right? So I'm going to do the cation, the anion, write the formula, and then name it. Okay? So let's look at the first one. Sodium is my cation because it's my metal. Sodium has a +1 charge because it's in group 1. Oxygen has a -2 charge because it's 2 electrons away from neon. Okay? So Na+1 and O-2. Do the charges cancel? The answer is no. Therefore, I'm going to crisscross the charges. So the 2 is going to go to sodium, and the 1 is going to go to oxygen. Therefore, the correct formula here is going to be Na2O. Okay? And when I write it as a subscript, I'm going to drop the charges. Okay? So to name this, it's going to be sodium oxide. Easy? All right, let's do 2 more. So lithium is going to be my cation, +1. Bromine, -1, group 17. Do the charges cancel? Yes, they do. So lithium +1 and bromine -1 Charges cancel, therefore it'll be LiBr, and it'll be lithium bromide. Easy enough. Last one, and then I want you to do the last two by yourself. So calcium is my cation, Ca plus 2. Fluorine is my anion, has a -1 charge. Okay? So calcium plus 2, fluorine minus 1. Do the charges cancel? No. So 2 goes to fluorine, 1 goes to calcium. Therefore, it would be CaF2. And then I'll name this as calcium fluoride. Okay? So you're going to go ahead and do barium and sulfur and aluminum and nitrogen, and I will check those tomorrow for your homework credit. Thank you.